Hello everyone, I'm Noah Rosenfield. Today we're going to be going through the basics of creating a user interface in Unity. We'll cover creating a new project, an introduction to the editor, game object basics, camera basics, and the Unity UI and Canvas system. By the time we finish, you'll have a clickable button that communicates across scenes to a click counter. Go ahead and hide this full screen and let's get started. So there's a couple prereqs. We assume that you already have the Unity Hub, which is what we're looking at right now, installed. A Unity editor installed through the hub. You can see through the installs here is where you're able to install a different editor or one should you need it. I have Unity 6, that's what we'll be using. And we also assume that you have some kind of a code editor. I'll be using VS Code. So I'm going to go ahead and click New Project. My location, we're going to go into the Unity tutorials. That's where we're going to create it. And my project name, we're going to call this Unity UI Tutorial. And I'm going to go ahead and click Create Project. We got Universal 3D selected as our project template. That'll bring in the basics that we need to work with, even though this is going to be mostly a 2D project working within the Unity UI and Canvas systems. It's totally fine that we select the 3D template. Won't really affect anything for us at this point in time. The first thing we're going to do is we're going to go through a quick run through of the Unity interface, what we're looking at when we boot up our project. All right, so you can see off the bat, we've got quite a number of options here, different panels, different buttons. So I know it's gonna be really overwhelming, but don't worry about it. We're gonna cover everything and you'll be in a good spot. So this actually, by default, you're probably seeing something like this. This is the default layout within Unity 6. So we've got a few different tabs. So you can see our hierarchy tab on the far left, scene, game, inspector, project, and console. These are the primary panels that you'll mostly be working with when building out your Unity project. Now I'm going to switch this to a layout that I have made ahead of time, which I find works well and particularly is good for recording because I can move things around so that my little video isn't blocking anything. So again, we've got those same panels. And we'll run through these now. So starting with the top left, the scene panel. This is the primary view for your game scene. A scene is the largest container that Unity offers in terms of building something. Everything exists inside of some scene. That's as big as you can go. Then we have the game view. This is what is rendered through the camera that is looking at your scene. This is what the actual output will be and what your player will see when you run the game. Up next, we have the hierarchy, and this this was not expanded by default. This sample scene is loaded in. I'm going to expand this out, and you can see a brand new empty scene from Unity comes with a few basic game objects. The main camera, a directional light, and a global volume. I'm going to go ahead and click on the main camera game object. I'm also going to head back to the scene view so that we can see it here within the scene. So now it's really hard to tell. This camera is what's rendering our game view. We're currently looking through the camera right now. This is what we're seeing. Not a lot there yet. But if we go back to our scene view, we can see here is the actual camera itself. There is the directional light, and there is our global volume. The inspector panel. The inspector panel shows details and properties, components that exist on game objects. So every game object, when you click it, it has a series of components, or some of these components are sort of baked into the game objects, such as a transform. This represents its location within the scene. You've got X, Y, and Z axes for position, rotation, scale, etc. Down here we have our project view. The project view, I'm going to go ahead and compact this at first, and you can, if you option click or alt click, this will either, while you expand, if you hold down the Option key, this can either expand everything out or contract everything. So you can see by holding Option while I expanded the assets, it actually expands every folder inside of the assets folder. So now it's a little overwhelming. We're going to go ahead and close all that up for now. So at the at the top level of your project, you've got assets and packages. Assets is the primary directory that you're going to be working in. Pretty much everything that you make, all of these scripts, your images, your sound effects, all of that is going to go inside of your assets directory in some capacity. And lastly, we have the console panel. The console panel is where we get our output when we have a debug statement or we're logging things. This errors, warnings, all of that will show up here in the console panel. So I'm going to go ahead and actually real quick bring in our little lesson plan here. Okay, so we've gone through the prereqs, we've created the project, we got our quick interface tour. So now let's talk about project organization. These are the folders that we probably want to create very first thing, even before we start making components or adding things to our scene. We're going to need places to put these things as we create them. And so we're going to start with project organization. So here are the folders that we're going to create within our project. And we can do that. We're going to, in our project panel, we're going to go inside this assets folder, right? You can see there's already a few things in there that none of this is, except for the scenes. The scenes is important. There it is. That scenes folder. You'll see that actually already has your sample scene inside it, right? So now we're going to go ahead and create the rest of these directories so that we have places to put our assets. We're going to create a folder for art. We're going to create a folder for audio. We're going to create a folder for prefabs. We want another one for ScriptableObjects. Another one for scripts. And let's see, did I miss anything? Scenes already made. Oh, and third party. I like to do one more for third party scripts and things like that, which are brought in not through Unity's package manager. Unity has a couple different ways that you can bring in assets that you're getting from the internet or from some trusted source or whatever it is. They have a package manager which offers you a few different ways to bring in these assets. Alternatively, you can just you may have instances where you're just copying and downloading files, downloading scripts directly from a tutorial or getting them off of ChatGPT or whatever it is. And you want a place to, to put these external third-party written scripts. So in this case, we're going to have our third-party folder. There we go. And that should be it. All right, so we'll start with, let's see, the Unity scene, GameObjects, placement, hierarchy, and components. All right, so we talked a little bit about this already. Any game object you make is going to show up here in your game object hierarchy, and you place it into your scene view here. So if we go to game object and we create empty, you'll see, oh, here it is. We created a new item in the hierarchy just called game object, and you can see it's that selected and placed that empty game object into our scene view. I'm going to go ahead and just call this empty game object. You can, I'm actually going to go ahead and, let's see, I think I can lock these other items to keep me from touching them. So the empty game object, you can move it around, and it was hard to see, right? We got nothing in it. It's empty right now. So actually, let's improve our ability to see what we're doing. We're going to add a component to this. So actually, game object, rather than an empty game object, let's go ahead and make something that we can see. We'll do a 3D object. We'll do a cube. And there it is, our cube. It also comes in at 0, 0, 0. We're going to go ahead and grab it. All right, so you can see we'll get rid of that empty game object. No reason to have it there. So within our scene view, we now have a cube. We can affect the position of this cube by dragging its properties in its transform component. We can also manipulate it directly within the scene and specify particular movement axes based off of how we work with this gizmo. You know, if we drag a particular handle versus if we drag a particular plane, we can, you know, affect how exactly we're moving this this game object within the scene. And we can, of course, you know, we have different tools here. You have the rotation tool where you can again affect, you know, the rotation of this. Looks like we also have some scaling tools, a rect tool, some other tools up here. But for the most part, you know, you're going to be either using the transform, so the hand tool, which is just the pan tool, allows you to move, grab, and drag the scene around so you can change your view. You, of course, can also change this by scrolling up and down to change your zoom. And if I hold down the Option key and then click, I can drag my scene view around to change it. Not holding the Option key just does a pan. Holding the Option key does a rotate. All right, so we've got our cube. The cube. Okay, so this is just a game object at its core that has some components added to it, right? If we look back at our, you know, create that empty game object, it has a transform. We can actually go ahead and right-click into here or in these triple dot, this context menu as it's called. If we do reset, it'll bring us back to a default transform 0, 0, 0 all across the board, scale of 1. Now, this game object, double-clicking will focus a game object in the view. So if I double-click the cube, it brings it to that. Double-click the game object, the empty one, you can see it's here. It's somewhere here, right? We can't really see it. We know it's there. There's nothing on it though, right? Unlike our cube, which has a mesh renderer, and a box collider component. So if we wanted to start adding components to this to create something, we can do that through this Add Component button. We could add our own mesh collider or our own, where's the mesh itself? Let's see, the mesh renderer needs a mesh. Cube, mesh filter, add component, mesh filter. There we go. What kind of a mesh? Capsule. Sure, why not? All right. So now we've got a capsule component that we've created here. Looks a little funky. I think that probably has to do with the, based on the material or lack thereof. Let's see, what's the deal? Oh, the materials, yes, here, mesh renderer, one material, lit, this one, here we are. We had a material available, but it's not assigned. So we can go ahead and assign that to, where's the default lit material? None of these look quite right. Spatial mapping, default material, frame debugging. What's this one got? Lit. It's lit. That's a good question. I'm not sure why this is not available for selection here, but if we copy and paste those component values, so we're able to, with our components, right-click this context menu. You can copy the component itself, right? And then you can either paste the entire component as new, or you can paste the component values. In this case, because I am, I already have this mesh renderer component here. If we remove this component, and then I ask to paste the component as new, here you go, we get that mesh renderer. Alternatively, you can paste the component values, and it will override whatever was in that existing component with wherever you paste it from. Let's see. Placement, hierarchy, surrounding components. Okay, so from here, we've started to populate our scene. And if we look over in our scene view, you can see here, we've got our cube, and here's our capsule, our main camera. If we start to raise the camera up by increasing the Y value, you'll notice in our game view, which again, this is the render from all of the cameras that are rendering out to a particular game view, in this case, display 1. This camera, this is the actual camera that's rendering it. So when we bring the camera further down in the world, right? Here's our overall world. When we bring it down, we notice we're way below now, way below the rest of our scene. If we bring it back up, now we're back above our scene, and we're basically just doing this exact same thing through the scene view, right? Okay, so we've got some game objects. We, can move them around our scene. We are able to, we've got, this one's a capsule. We'll name it capsule. We've got our cube. Okay, so all well and good, but from here, what we want to start working into is the camera and the canvas. So we've already covered camera placement, camera movement. Let's go ahead and look at things like the projection and the field of view. So, or size as it would be in orthographic. So for the field of view, and actually we'll go ahead and move to the game panel while we do this. Watch what happens as we change our field of view, right? We are narrowing. It looks like we're getting further away or closer to it, but actually what we're doing is, if we look at this from the top down, so there's our camera. These lines represent the field of view, right? We're get a little closer here so you can see there we are. So now we're right behind it, all right, and a little bit above. Wow, that's a big field of view. So you can see as we bring this down and our field of view is smaller, the objects in that view take up more space. So just a note there on field of view and how that can affect what you're seeing within the scene. Not actual distance of the camera, even though it has that same kind of an appearance, right? If I pulled the X, if I pulled the Z, if I pull the Z way back, you kind of get a similar effect. But these are two very different things that are happening between changing the field of view and affecting the transform. So this is not going to be super important for us right now because of what we're actually going to do with our projection, which is changing it to orthographic. So if we look at this, orthographic, what that means is that it's not a perspective view where the distance from the camera to the object, that doesn't affect how the object is rendered. We're essentially pretending that all of these objects are a fixed distance from the camera. You'll see as I move this, the capsule, right? As I move it back, and I can't actually see it in the scene here. Let's see what's the best way to display this. Here's our capsule. Where's our main camera? Here's our camera. Here you are. So you can see, this actually gives a pretty good representation of what's happening. The camera now is rendering a plane, and no matter how far away or how close things are, those objects get flattened onto this plane. You can imagine the plane moving towards them like this, and at the point that it contacts the object, boom, there's the square. It renders that square as it is. And boom, here's the capsule. It renders that capsule as if it were directly on the plane, right? So that's why even though this capsule is way far away back at 37, if we bring it down closer, you'll notice nothing changes until, now it disappeared. Why is that? It's behind us. That's why. So we bring this back in front of us, and you can see there we are. We've got our regular capsule again. So for UI elements, an orthographic perspective is often what we want because we generally don't want like a HUD style UI or most UIs. We really don't need them to have perspective. They are right at screen level for the user, right? Unless it's an in-game sort of like, you're running through the game world and there's a UI, some kind of a signpost or maybe a keypad or whatever it is that's actually built into the game, that would be not using, you wouldn't want to use a perspectiveless camera for that. We'd be using a regular perspective camera. So let's go ahead from here. I think the next thing up is our canvas. Yeah. All right. So, before we do that, the size. So with orthographic projections, we don't have a field of view, but we do have a size, right? And this size represents the number of in-world units that are half of the height. So, this is kind of weird. It has to do with how camera sizing is calculated and how it's talked about. But what size means is the distance from the camera to the top of our render plane. So it's essentially half the distance of the total height, and then this depends on the aspect ratio as to whether or not, the rest of the side, the width of this camera, right? That's kind of based around the aspect ratio of the camera. But the size specifically refers to half of the total height. So from here, if we go ahead and start thinking about canvases, all right, we're going to add from the UI a new canvas game object. So here it is, the canvas. It comes into our game object hierarchy, and the only difference, or at least one difference, is it has been added to the scene, but it hasn't been added in the same way as everything else, right? You can see here, we've got our cube, we've got our capsule, everything is kind of sized appropriately, and then there's this canvas, which is friggin' huge. Look at how, oh my God, look at how big it is. Why is this canvas so enormous? Well, that's because the render mode of this canvas is screen space overlay. So what we're actually seeing here, even though it's placed in the scene view, this is not an object that's being rendered by the camera. The canvas is currently being rendered as an overlay onto the screen. Now we haven't added anything to the canvas, so you can see our game view looks exactly the same as it did before. So we'll add something and we'll see how it appears in just a moment, but that is what you're seeing here. That is why this canvas looks so massive in the scene, is because this is actually representative of the player's screen, not an in-world object yet. So you can see here's the width and the height. These represent, I think actually if I change this around, yeah, so you can see here, even by changing, even in the editor, right? It's kind of crazy. Inside the Unity editor, because the render mode of the canvas is screen space overlay, and this here, this area in the game view, this is my screen. It's being told that this is the available screen space right here. So when I change the panel in my editors and I widen this out, you can see the X position, the Y position, the width, the height, that is all changing in the inspector as well, because the canvas object is updating itself to fit the available screen space. So what if we change the render mode? All right, so now we're going to start to look at some other options. Here's screen space camera. You can see right now it says a screen space canvas with no specified camera acts as an overlay canvas. So nothing has changed. It still is pretending that it's a screen overlay camera. Now this is a screen space. This is actually screen space. This is a little misleading. This is really camera space in a way. You can imagine that when we assign this main camera as the render camera, we are now pretending that this canvas object, which again we saw in the scene, it's this. It was a big flat plane here. If I go back to overlay real quick, you can see here it is. It's just this big flat plane. And when we change to screen space camera, we're now saying, oh, okay, so the camera is looking at our game world whatever it sees, it's going to return that as the render that gets passed to our game panel. And then after you render that, go ahead and render the canvas right over the top of it. So right now our canvas is totally transparent, which is why we're seeing everything, seeing just our regular game scene. We don't see anything different if we turn the canvas on and off. But if we add to this a new UI object, let's go ahead to go to our UI, and we will add an image. Why not? Sounds good. Okay, so we've got our canvas component. We've got an image which has come in as a child of this canvas component. Instead of a regular transform, canvas components, or the sub game objects of canvases, they get a rect transform. So this is specifically working within the space of the canvas itself. So the rect transform offers some different options. It still has positionality on the X, Y, and Z. It still has rotation and scale for the X, Y, and Z, but it has some other options here as well. Right now you're seeing width and height, and there's anchor points and a pivot point. So this works if you're at all familiar with web layout. This is not dissimilar from the way that a web page is laid out. There are some similar concepts here, right? So we have a rectangle at our base, essentially. That's why it's called a rect transform. Everything is going to be a rectangle to some extent. And if we want to say, okay, in this case, the left-hand side of our rectangle, this is x equals 0. And the bottom of our rectangle is y equals 0. So what that means is I still have my image. It has some positionality right now, and you can see I can move this around, and it will change, where it appears in both the rendered, it's changing the where it is on our canvas. Here you go. Now that we've got this image in here, you can kind of get a better view of the canvas itself, right? Here's the image, and then that is being rendered directly over the top of whatever else our camera is seeing. So we've given it a width of 100, a height of 100, here's the positionality. And right now, all of these anchor points, the X, Y, min and maxes, they're all set to 0.5, which is the center of this item, which, as you may notice, is actually why we're seeing this transform show up right in the center. So what we just said before, left-hand side, x equals 0, right-hand side, x equals 1, bottom, y equals 0, top, y equals 1. So if I wanted to put everybody in, or we'll start with the pivot point. If we want to put the pivot point in the lower left, that would be x equals 0. Oh, see that update here? Our transform component, our pivot changed. And so now the gizmo always is placed on the pivot point of the object. That gizmo is now showing up at x equals 0. And if we change the y pivot point to 0, it's now in our bottom left. Now, the anchor points. This controls the sizing of the object relative to its parent object, right? Again, going back to, if you know anything about web layouts and web UI, this is sort of like the, the top, left, bottom, right, those CSS properties are kind of similar to working with anchor points. So right now we're saying that, this is an absolutely positioned item. We're not using positioning relative to our containing object at all, but because all of our anchor points are in the exact same spot. So when all of your anchor points are in the exact same spot, it gives you the option to size this thing absolutely by providing a width and a height and providing your positions here. Notice this X, Y, and Z positions, okay? So if we change our anchor points to say, okay, I want this game object, which is a sub game object of my canvas game object, I want this image to not be an absolutely positioned, I want it to be relatively positioned to the canvas. And so what we can do here is we say, okay, I want the top left of my, or sorry, not the top left. Well, so we'll start with the X component first. I want the left side of my image to be equal to the left side of the canvas, of its containing element. So I would say I want my anchor point to be x equals 0. Now, off the bat, you can see some things already changed in the rect transform. As soon as I changed the pivot point, and I wonder if we can, there we go. I should have probably done this a little bit earlier, but I think it was helpful to be able to see some of this stuff. So I have changed in my gizmo here, rather than using the move tool, which shows us the traditional gizmo, I have flipped over to the rect tool, which shows us the anchor and pivot points of our rect transform. Now it's a little hard to see. The pivot points they're not actually even the pivot points technically. These are the corners. These are just like the actual corners of the item. But the pivot point, you'll notice it's a little hard to see. It's down here though. You see this? There's an extra little circle. I don't know if there's actually any way I can get this bigger. There's a little circle over here that's right around the lower left blue dot that's actually indicating this is the pivot point. When I move the Y value of the pivot up, you'll see, oh man, that was really fast. There we go. You'll see if I'll just do 0.1, there we are, 0.2, 0.3, here it is. That pivot point is slowly sliding up the left-hand side of this image. For right now, I'm going to set it back to 0. Okay, so back to the rect transform. So because I have now said that my min anchor point for this image is at 0, which is the leftmost point of my containing canvas, it now gives me a relative positioning. Rather than being absolute, we're now working with relative positioning. Left, which is how far from from that leftmost side, that 0, x equals 0 of my containing object, how far from that left-hand side is my left-hand side, right? And so that's what this left controls. If I set the left to be 0, what we get here is that I'm saying, okay, my anchor, my X anchor is at 0. It's at the leftmost point of my containing object. And my left side is 0 pixels from that point, which is why we see our image now lines up with our canvas. If we increase this left a little bit, we'll see the image starts to move off of the left-hand side. We're increasing. We're saying from my x equals 0 pivot point, go 49.3 units. And that's what this gap is now representing. I can also go negative. I say from that leftmost point, go negative 58.2 units. And you can see now it's getting pushed off of the canvas. So these anchor points are all relative to the containing object. By clicking this little graphic here where it tells you middle custom, this gives you some information around the current anchor points and the pivot points and all that. If you open this out, and you can see here, holding shift sets the pivot, holding alt sets the position. So a quick way that I can, kind of get some of these presets, like let's say I wanted to get my pivot point. I set my pivot point to 0, x equals 0, y equals 0. That is the left and the bottom. If I come in here, you see shift sets the pivot point. If I click down here, bingo, there you go. This changes the anchor points also, but it sets the pivot point to that 0, 0. If I go to my top right, if I click here, you can set the pivot point there or whatever. So what I'm going to do right now is I'm going to center the image inside of its container, the canvas, and set all of its anchor points to be basically to match the canvas. The minimums are going to go to 0. The maximums are going to go to 1. So I'm going to hold the shift key, the alt key or the option key, and then I'm going to click this bottom down here to allow it to expand fully. And so now what we've got is an image that takes up the entirety of the canvas because the anchor points are at x equals 0, y equals 0, x equals 1, y equals 1, right? So that means all the way across the canvas from left to right, all the way across the canvas from top to bottom. And you'll see my left, top, right, and bottom, those values are also all 0. So I'm saying go to that rightmost point and then go 0 pixels from there, which obviously keeps us right in the same spot. If I wanted to put some extra distance between the bottom anchor point and the bottom of my image, I will increase this bottom value. You can see it starting to bring up the bottom. If I want to bring it in from the right-hand side, I can increase the right-hand value there. And you'll see sometimes when you're working with these things, sometimes the editor will, it's got these little floating point values. You can see we've got, 9.5 whatever exponents to the negative 0.5. So this is basically 0. It's just a thing that the Unity editor likes to do. You can always come back in here and manually reset it. It can be annoying and it doesn't affect, like, these tiny little values. They're not really going to affect the actual output of your rendered scene in the long run. So try not to sweat it, but it can be annoying and it can be something where you do need to actually, if you want to make sure, oh, there, that one set itself back to 0, but sometimes it does not. And like, there we go. And so now if I really want to have this look super clean, I have to come and reset this to 0. But, oh, and you can see now it's giving me an issue. It doesn't even want me to do it. It's doing some small calculation and this floating point is getting stuck in there. So anyway, not to worry. In this case, we'll just reset this. Oh, okay, so I reset it and it went back to its original, which is again 0.5 anchor points all around, which means, we're looking at the anchors are all pulled to the center of the object, which means that we're going to be defining its size absolutely rather than relative to its containing object. And now you can do this on an axis by axis basis, right? So let's say that, I know that I want to be defining the width absolutely. So I set my anchor points to 0.5 and 0.5, and I say that the width should be 100 units. But my height is actually supposed to not be absolute. It's supposed to be relative to the container. I can change just the y values of my anchor points. And now I can have something that has a absolute width of 100, but the height is now relative to the container. And in this case, because I've said y equals 0 for the min, y equals 1 for the max, and 0 pixels off the top, 0 pixels off the bottom, we get something that expands to the full size of the container. Again, in this case, the full canvas. So, what we want to look at next, canvas scaling. And actually, before we go into canvas scaling, let's look at one more thing about rect transforms, which is nesting, right? So what I can do here, I'm going to take my image, I'm going to give it an anchor point in the top right, and then I'm going to tell it to, and actually I'm going to give it anchor points in the top right and the middle of my canvas. The lower left point of the image, I'm going to put it in the middle of the canvas. So how would I do that? All right, so I know that my min x is 0.5. That's halfway in. Okay, good. I know that my min y should be 0.5. That's halfway up the canvas. And when you change these pivot values, you'll notice the size of your image in the scene, it doesn't actually change. It holds its current display and it automatically updates the values in your inspector to match what you have laid out in the scene. So when I change this anchor to 0.5, you'll notice that my bottom property now is 212 pixels. We're saying that off of 0.5, which is the middle point, set the bottom of my image 212 pixels below that, which is what happens to correlate to the bottom of the canvas right now. When I bring the bottom up and I bring it to 0, now we're saying that we want it 0 pixels off of the bottom anchor point, our min y, which is halfway, 0.5, up the canvas. So the max x, we said we want this to be all the way in the top right of our canvas. So I'm going to change this to 1. I'm going to remove these values for the left and the right. And now you can see by setting these anchor points and clearing out the left, top, right, and bottom values, we have an image that is occupying the top right quadrant of our overall canvas, right? And you can see the pivot point is 0.5, which is in the middle of this image. If I want to move that pivot point over, you know, you can, if I set this to 0, it'll go to the far left. If I set this to 1, it'll go to the far right. But right now, we'll leave it there. All right, so again, as with a web layout, it's relative to its immediate parent container. So if I make another image and I put it inside of the previous one, now what's going to happen, right? And we'll go ahead, we'll change this so that we can see it. I'm going to make this red. So you can see when you drag and drop components around and you move them around in the game object hierarchy, a couple things happen. On canvases, the render order goes top to bottom in terms of what is rendered first to last. And remember, the thing that is rendered last is, these is painting, basically. Rendering is painting. So you can imagine we have this you know, we have a canvas, we have an easel with a, you know, a blank canvas on it. And we say, okay, render image 1 first, or render this image first. This image is gray. We paint the whole thing gray. Then it says, oh, I have below you, further down the hierarchy, I have another image which is red. Paint that whole thing red, which is why we're seeing the red painted over, and in our game view, here it is, you can see we're seeing the red painted over that gray image. If I reverse these, we will see the red painted underneath and then the gray painted on top. I'm just disabling this top object so that you're able to see what's underneath it. So the red image is now back on top, and we can affect our, right now it's not a child of this image. These are both children of the canvas. You can see they are at the same indent level in our hierarchy, both children of the canvas. If I take this image and I drag it and drop it on top of the other image so that it becomes a child, you can see now we've got 2 indents worth. A couple things happen. The rect transform updates again visually. It maintained the visuals, it maintained its placement, but the values of the rect transform have been updated appropriately to maintain its size, whatever the size was, and the positioning and all of that. Before the drag and drop, before the reparenting, those values get updated to keep that same placement and all that. So what I'm going to do here is, if I expand this back out, right? So this is not going to change much. But if I say, okay, of my parent now, right? I'm going to do this lower left, or sorry, the lower right with the Alt and Shift, right? I use this shortcut a lot. This basically says expand out to fill 100% of your parent container. It's a good place to start. So here we are. We've got our anchor points again. You know, again, 0 to 1 from left to right, 0 to 1 from bottom to top. No 0 pixels off of that, you know, off of that that left, right, top, and bottom. 0 pixels off of it, so exactly where it is. So now, if I wanted to again say, okay, the same as we did with our initial image, right? I said the left halfway into our canvas, 0.5. halfway up our canvas, 0.5, and then the top right, 1 and 1. If I do the same thing for here, 0.5, 0.5, 1 and 1, clear out these left and bottom values, you can see that, again, what we've done is now the exact same positioning, but relative to the image that we just made. We're now in the top right quadrant of the parent transform, which is in the top right quadrant of its parent's transform. If we wanted to move this to the lower left, I can shift the min to 0 for both of these and the max to 0.5. And so now once I move these left, top, bottom, and right values, we will see we are now in the 0 to 0.5 of the x and in the 0 to 0.5 of the y of the parent transform. Okay, so this kind of layout system where children are relative or can be positioned relative to their parent transforms, this is an extremely useful tool for laying out responsive UI, because we can position things and size things relative to their parents so that no matter how big our game screen gets or how little it gets, this is positioned relatively to all of that, and it always occupies 1/4 of the space. And now you can see here, if we, oh, this got a little wonky. I'm going to go ahead and just reset my layout. There we are. Okay, so yeah, so this canvas, right, rendering in the screen space of the camera. And we've got our images set up like so. And we've covered the anchor points. We've covered the pivot points. I think that that'll be all pretty good to get us started. Let's go ahead and jump into whatever the next item is. Oh, canvas scaling. All right, great. So if we look at our canvas, we have a canvas scaler. And right now this is set to constant pixel size, which actually, let's see if we can demonstrate something with that here. Let's see. So rather than having these things be relative to the canvas, what happens if we move them back to a specific pixel size? Okay, so what I've done here is I've centered, this is another shortcut, to bring everything to the center, the pivots and the anchor points, Alt, Shift, and then clicking this middle box, right? So this bottom right box expands to fill the parent. The middle box contracts it all the way down. So this image, right? Okay. It's in the middle. We've got the width, we've got the height set, and we have this on a canvas that is set with constant pixel size. And so you'll see here, look at how this differs. Because we said that this image is now, oh man, it really likes to mess with my thing, huh? Layout, recording. Okay, just gotta be careful about bringing it back, that's all. Okay, so now look at what's happening when I resize our game view. This is because instead of being relative to our canvas, we have said that this image is absolute. All of the anchor points are in the center. We're giving it a defined width and a defined height. And because the canvas is set to a constant pixel size, as we change the size of our view, the UI, or sorry, the image item, the image elements, they don't change size at all compared to when we set this relative to, let's see, go back to, nope, not that one. 1 and 1, 0 all this out, right? So back here, when I adjust this, now it scales with the game view. So That has to do, that's because we have this constant pixel size enabled here, but we're doing relative sizing relative to the canvas size, and the canvas size is being controlled by the screen space of the camera, which is controlled by how big or small we make our game screen. It's a mouthful. So if we go back to what we were doing a moment ago, which is we're going to bring everything to the center, we're going to say, okay, I don't want it positioned relative to anything. I want it to be in the middle. I want it to be 500 pixels wide. I want it to be, 300 pixels, 300 pixels tall. And now our canvas, instead of, right, so this makes sense, constant pixel size. We scale this, it doesn't change at all. Constant pixel size. If we change this to be scale with screen size, now we're going to be scaling the canvas, right? We're scaling the canvas with the screen size, and you have some screen match modes here, width or height. Right now we have it set to width. You'll see when we do this, now it does, in fact, even though our image is absolutely sized, because the canvas is being told to scale with the screen size, when we change the screen size, the canvas size also scales. We can also use the screen match mode of width or height to affect the presentation of the images in the canvas. So as an example, different users are going to have different screens with different aspect ratios, right? We're not able to control always the aspect ratio of the user's end screen. Some people may have like an extra wide monitor. So I'm going to go ahead and right now I'm going to switch our game, the camera aspect ratio or the screen ratio to free aspect, right? So now it's just fitting to this view right here. And I'm going to go ahead and try to mimic, let's say this looks kind of standard, looks like kind of a standard screen size, right? And I'm going to set the image. Okay, so if we want to take an example, kind of a standard game example, the kind of thing you might have is like a nav bar, right? We might have a nav bar somewhere. And that usually is going to sit, along the top or bottom of the screen. I'll go with the bottom at this point. And it's going to go all the way across the screen from 0 to 1 on the x-axis. And we're going to say it's supposed to have a standard height of 100, right? And so that looks about right maybe for how big my nav bar is going to be in my scene or whatever. So if I go to the canvas, back to our canvas component, you can see when I change this, right, based off of this image trying to always stay matched to the full width and maintaining a height of 100, if I tell my canvas, my rect transform of my canvas through the canvas scaler, if I say we're going to match the width as opposed to the height, right? So now watch the width. Watch what happens when I scale this out, right? If we pretend that this screen is a lot smaller, right? Oh, okay. Look, you see how the nav bar, right, our image down here, is actually shrinking. And as we get a wider screen, our nav bar is now taking up more and more of the screen. Now it's taking up way too much of our screen. This is supposed to be gameplay space, not nav bar space. And that's because we currently have our canvas scaler set to be matching the width. And so it's trying to maintain a particular ratio based off of the screen width. Now, so if we set this over to be the height and we say, okay, no, don't use the width, use the height of the screen, which is especially for, for a desktop output, right? The height of the monitors, that doesn't really change exactly in the same way. You usually don't have an extra tall monitor. Usually it's the width that's changing. So we say match the height, and as a result, when we resize our screen, the nav bar stays at that same height because the canvas has a constant height of 600, matching our reference resolution of 600, and the image has a height of 100. So it's 1/6 the height of our overall viewable area. And it maintains that height because we're saying match the height, as opposed to matching the width, which gives us this resizing nav bar, which is probably not what we want. So anyway, just one more thing, you know, this can definitely, there's definitely a few things that are kind of coming into play here. You know, it matters how you have your canvas subcomponents positioned and sized. It matters what you have set for your, you know, your canvas settings, the canvas scalar settings, and it matters what your expected, you know, screen outputs are going to be. You know, what aspect ratios you need to target. And so those things combined, you can use the canvas scalar tool to kind of help you, you know, resize your UI elements appropriately as you're dealing with different aspect ratios and screen sizes. So anyway, we're going to stop here for today. We're going to get into buttons, animations, and that cross-scene communication. We're going to get into that in our next video. Thank you very much for watching. If you have any questions at all, please do reach out. Happy to help.